Okay, so I guess we are ready to start. So, firstly, good morning, everyone. I am really delighted to welcome you all to Data Structures and Algorithm Workshop Day 2, organized by our GDSC. So, today we are privileged to have an expert speaker, Professor Piyush Kumar Soni, Assistant Professor at NMIMS MPSTME Shirpur campus, with an extensive experience of 9 years. This workshop will be focused on the core topics of data structures and algorithm, such as vector, linked list, stack, and queue, and their implementation using the standard template library in C++. I'm confident that this workshop will be highly informative and the knowledge and skills you gain from that will be invaluable in your career as a software developer. So make the most of this opportunity, ask questions, and actively participate in the exercise and projects. Once again, welcome to Data Structures and Algorithm Workshop Day 2. We are thrilled to have you all here and hope you all enjoy the session. Thank you. So now I request Piyush Kumar Soni sir to begin with his workshop.
Okay, thank you, Aman. Good morning, all. Am I audible, Aman?
Yes, sir, you're audible, sir.
Let me start sharing my. Uh, just give me a minute. Okay, so is my screen visible?
Yes, sir, it's visible.
Okay, good morning, all. In yesterday's session, we had discussed about the basic concepts of few data structures like array, linked list, stack, and queue, and how to implement the operations on those data structures, what we call using hard coding approach. So today we will briefly go through uh, the standard template library in C++ and the different uh, templates and functions available. Then in most of the session today, we will be discussing about problems and their solutions using STL library. Okay. So today's agenda is we will briefly go through template function and classes, like a knowledge of template function and classes is required to understand the concept of standard template library. Then inside standard template library, we will be going through different components like iterators, algorithms, and most importantly, the containers. So in the containers, we will be going through vectors, queue, and stack. And there is another component called functions or functors. We will skip this one in today's session. So a template is a very simple component, but it is very powerful tool in C++. And generally what we do in template, we pass the data type as parameter. And we don't need to write the same code for different data types. Like for example, we can talk about sorting algorithm. So if we require, or if an organization requires sorting of list of different data types. So if we can write a template for sorting, so we need not to write different sorting implementations for different data types. We can only provide the data type as an argument or parameter to the template, and it will work for each data type. We will look at an example. So two basic keywords are used while we will be using templates. One is template, another is type name, and which type name can also be replaced by the word class. And we need to know that templates are expanded at compile time. It is just like macro expansion or macro functions. So the difference between macro functions and templates is that in macro function, the call is replaced by the quote. But here, the source code contains like data type. So it will also supply the data type as well. So just look at this example. This is an example of function template. So at here at the left hand side, we have defined a template function just to return larger of two values. So we have generalized the data type as t here. And like inside main function, we are calling this template function, and here you can pay attention. We are supplying the data type. Okay. So we need to supply this data type int. If we want to find larger of two integers, we need to supply data type as character if we want to find the larger of two characters. So what will happen at compile time? These two definitions will be added to the code. Like one is for integer, another is for character. The same template function. So that is the advantage of using template functions. Template classes are similar to template functions. Okay, and like we some common functionalities if we want to use for different data types. Then we can define a template class for the same. For example, like this is just for demonstration purpose. There is like no significant function defined here. So here we have defined a template class which will be displaying or printing the array irrespective of the data type of the elements of the array or data type of the array. Okay. So again, we have defined this template class array. Okay, and using a pointer variable and size attribute, we will be displaying the elements of array. And here in main function, you can see that this object A is created for integer array and this object B is created for character array. And then we can call print function with the object name, and it is like this will work. This will be printing this array with integers, and B dot print will be printing this array with characters. So this like basic concepts or knowledge about template functions and template classes was required like for the discussion about standard template library in C++. So which is a set of template classes and which provides program like common programming facilities for data structures and functions. And it is a generalized library and its components are parameterized. Okay, like since it is template and the parameters would be data types. And it may be other parameters as well, but primarily would be data types. And the key benefit of using STL is that it provides a way to write generic. Why generic? Like we can use the code for any data type by just only supplying the data type. Reusable code, same code will be used for different data types. Okay. And the primary components for STL are iterators, algorithms, containers, and functions. So we will briefly go through iterators, algorithms, and containers in today's session. And then we will be discussing and working on problems and their solutions using STL. So iterators, like as the name suggests, it is used for iteration and iterating through a sequence. So they are like pointers to the memory locations for the elements in STL containers. Like we will be going through containers in the upcoming slides. So iterators are like pointers which will go through the elements, traverse through the elements of containers. So like they are implemented in such a way that they reduce the complexity and execution time of the program, complexity for us in writing the program, and they are like optimal implementations but reversing, so they will also save execution time. There are few basic operations available with iterators. One is begin. So this function is used to return the beginning position of the container, the first element. And we need to keep in mind, and like and function is used to return return a like virtual logical after end position, like then what would have been the next element after the last element, and will point to that position. So here we can see uh, an array is created, a vector is created. We will also go through vector in upcoming slides. So we have declared here we have created a iterator pointer, and like if we want to display all the elements of this vector, we will begin from the first element, and the begin function will return a pointer to the first element. And since we have all, as we have discussed, the end function will return a pointer to the an element virtual or logically which is next to the last element, so it will be less than pointer. And then we can use this pointer and increment operator to display the elements of this vector or array. Okay. There are few more functions like next and previous. So next function returns the new iterator pointer that the iterator would point after advancing the positions mentioned in the argument. Similarly, previous function returns the new iterator that the iterator would point after decrementing the positions mentioned in its argument. Just look at here, like we are creating two iterators, PTR and FTR. PTR will be at the beginning. Okay, it will have address of first element, and FTR will have like the address of the virtual logical next element to the last element. So next PTR3 will move this pointer ahead by 3. So it will move to 4. And similarly, previous FTR3 will move the FTR pointer by decrementing by 3. So when we will decrement it by 3, it will move to 3. So this is how previous and next will help us in moving in a sequence with certain number of locations in both the directions, forward and backward direction. Another function is inserter function, which will be like which we may use to insert a set of elements in between a sequence. So this inserter function is used to insert elements at any position in a container. Like it will have two arguments, the container, okay, and in which we are supposed to insert, and the position where the elements have to be inserted. So advance is like a next function. So we can directly like advance will directly set the pointer to the specified position. Okay. So pointer was at 1, and if we want to advance it by 3, it will be set to 3. And here the inserter function will insert this range of values. And we have created another vector AR1 which is containing 3 elements 10, 20, and 30. So these values from second vector AR1 will be inserted into first vector AR. And here second argument is pointer, which is the position from where we want to insert. So after 3, these elements will be inserted. So after insertion, the elements would be 1, 2, 3, then 10, 20, 30, and followed by 4 and 5. So these are the few basic functions that iterators have, and that like we must be aware, and that we might be using in solving the problems. So algorithms are like functions, and this header algorithm defines a collection of functions, and these are especially designed to be used by a range of elements. So these algorithms act on containers and provide means for various operation for contents of the containers. So there are a lot of algorithms available, but since like we cannot have an exhaustive list and discuss all those functions. So I will briefly be going through only these three functions: sorting and reverse and max. So like we need to pay attention. Like I will be devoting some time to this sort algorithm available with the template library. Okay. So sorting, we all know, like we want to arrange the elements in either increasing or decreasing order. So we do have sort function available with template library, and this is how we can use it. We need to give the like from where we want to begin and up to where we want to go, and it will sort those enlisted elements. So after this sorting, if we will print this array, it will print 1, 2, 3, 4, 5. But what is like I want all of you to focus on, like how it is going to sort. Okay, like which particular sorting technique it is going to use. So we had gone to, like we are aware about many sorting algorithms, and we know that like quick sort, heap sort, they work very well. Like those are the like most efficient sorting algorithms. Still, this sort function from template library works very well because it is a hybrid of quick sort, heap sort, and insertion sort. So by default, it uses quick sort. But if it gets to know that like the quick sort is not partitioning the list in equal like similar sizes, it is if it is unfair partitioning, okay, and it is going to take more than n log n time, then it switches to heap sort automatically. And ultimately, like towards the end of sorting, when the array size becomes very small, then to save time, it switches to insertion sort. So this is like a highly efficient implementation of sorting. So definitely this is going to take less execution time than what we will be writing, even if we use quick sort or heap sort. So reverse, like as it is obvious, it will with the name, it is going to reverse the elements of a vector, and max element will also give you the maximum element of the vector. So this is how we can use reverse function with the vector. We just only need to give the set of list of elements by specifying the starting point and the ending point. It will reverse it. And max element will, again, we need to provide the starting and ending point, and it will find the maximum element from this. So when we will reverse this list, it will display 15, 42, 23, 5, 20, and 10, and the max element would be 42. So these are inbuilt functions available with us in STL. We need not to like now we need not to write codes for this type of algorithms. So most important part of STL library are containers, and containers are like folders which uh, stores object or collection of elements. Okay, and these are containers are like they are class templates which allow a variety of functions, and like it supports various different data types. So the container manages the storage space for its elements and provides member functions to access them. Okay, it can directly access them, or like generally it will use iterators. So, like those basic data structures that we have discussed in the yesterday's session, all of them are like implemented in as containers in STL, and you can find this list of containers available with STL. So these are vector. Generally, it is similar to arrays. List is for linked list. We know that what we mean by double-ended queue, arrays, forward list is stands for like list will be for doubly linked list, forward list will work for singly linked list, then queue, stack, priority queue. So we won't be digging into the details for all of them. We will be only going through vectors, stack, and queue in today's session. So vectors are, we can say, dynamic arrays. So it is similar to array in all the aspects, except like these are dynamic. So it can, like they can resize themselves automatically. So when an element is inserted, it will, the size will be increased. When an element is deleted, the size will be decreased. And similar to arrays, vector elements are placed in contiguous memory locations, so they can access and traversed efficiently using iterators. So again, these vectors also do have functions like begin, point, like it will it will return a pointer that will have the address of first element, and okay, similar to iterators, it will return a pointer to the logical theoretical element that follows the last element of the vector. Similarly, we have R begin and R end. It will work in reverse sense. So R begin will return a reverse iterator pointing to the last element. R end will return a reverse iterator pointing to the theoretical element preceding the first element in the vector. So begin end will work in forward direction, and R begin and R end will work in reverse direction. So like I haven't told you about this pushback function in case of vectors. It will append the element at the end. So this is like very frequently used algorithm or like functions we can say for vectors. So pushback will append an element at the end. So like using this loop, like initially we have created a vector and we have specified the data type. This vector will contain only integers. So we need to keep in mind like we are inserting only integers in this vector. Okay, otherwise it won't accept. Then using this loop, we have inserted elements from 1 to 5 in this vector. So after this loop, it will be a vector containing elements from 1 to 5, and that we can confirm by displaying. And this again, this display will be, we can use begin and end property. And if we swap this begin and end pointers with R begin and R end pointers, what will happen? It will display the list in reverse order. Okay. So begin and end works in forward direction. Begin will give the address of first element, end will give the address of which may be possibly theoretical next element to the last element. R begin will give you the address of the last element, and R end will again give you pointer to the theoretical element which will be preceding the first element. These are the four operations which we can use to like iterate through the elements in forward or backward direction in case of a vector. Then these are few more operations available with vectors. Size will give you the number of elements in the vector. We can also resize like by specifying strictly specifying the number of elements to be kept in the vector. So if the vector contains more than n elements, it will discard the remaining elements. And empty function we can use, it will return true if the vector is empty. That means if the vector does not contain any element, it will return empty. Otherwise, it will return true if the container or vector is empty. Otherwise, it will return false. This is how it can be used. Now we will talk about stack, container, and we have already discussed what stacks are. So we won't be digging into the definition of stacks. So there are few functions available with stack container. The first is empty. Again, this empty function will return true if the stack is empty. Otherwise, it will return false. Size function will also give the number of elements in a stack. Top will return a reference or pointer to the topmost element or the top element of the stack. Push function, as we all know, we need to provide an element as an argument that we want to push onto the stack, and it will push the specified or element which is passed as argument to the stack, and again pop will delete the topmost element from the stack. So in as we have discussed in the last session, we do not have any choice as far as if you want to delete an element from the stack. So the pop function will not have any argument. So this is the sample code demonstrating the use of these specified functions about a stack. So we can push, like here we have specified a stack container, and like the elements will be of data type integer. So we need to keep in mind we can only push elements of integer data type to this particular stack. Then we can push elements using push operation. Then we can pop elements using pop operation. And we can also display all the elements of the stack by using this loop. Like until the stack becomes empty, we will be popping elements and displaying. Like using top, we will be displaying the top element. Then we will pop the element. So the next element will become top element. So in this way, it will display all the elements of the stack from top to bottom. Then now we will talk about queues. So again, we won't be digging into the definition of queues. So again, here the push function will insert in queue. The like we are also aware with the difference in queue and stack. So here, if we are creating a queue, the push function will insert at the rear end, and the pop function will delete from the front end. So again, this also have size, front, back. The front function will give the front element, back function will give the last element, which is the rear element. And push and pop function will work as we have discussed. Push function will insert the element at the rear end, and pop function will delete an element from the front end. Okay. And we can use this for loop to display the elements of the queue. Okay. So we wanted to keep this discussion very brief. So now we will be working on few problems and discuss their solutions using a stack. So now I will here I will take a pause of a minute, and I want all of you to go through this problem statement carefully and think about the solution. Okay. So it won't be possible to give much time for writing the solution and checking your solutions. But still, I want all of you to logically think about the solution to the given problems. Let me explain the problem statement, then I will take a pause so that you can think about the solution after understanding what actually the problem is. So what we want, we will have an array as input, like 1 to 1, and we want to create another array which is going to be exactly whose size is going to be exactly twice of this. Okay, and in the second array, the elements would be a repetition of the elements of the first array. Okay. So what actually we are doing, we are appending the elements of array after its own elements. Okay. This is what we expect. So now I will take a pause of a minute, and then I do expect all of you to logically think. Okay. And it would be better if you are having a pen and paper with you. So just plan the solution. And I know that we cannot expect a full-fledged code. So just try to write down the logic, how this is going to be done. So what may be the solution? Like we will create a second array with twice the size of the original array. So first we need to get the size of the original array. Okay. Then we will create another array with the size which is actually twice the original array. And what we can do then, we can copy the elements of first array in the second array twice. That will be the approach. Okay, look at this. We will copy the elements of first array. Then again, we will copy the elements of first array. So like this may be one of the solutions. So like here, like the problems that we are discussing, or in general, it is not necessary that it will have only one correct answer. As you all know, like in programming, there may be multiple correct answers. Okay. So here we have created a vector, then just inserted 5 elements in it. We have stored the size in a variable n. We have created another array, and look at here. Like first we have inserted elements of the original array in the second array by using pushback function. Okay, so we can also use indexing in vectors. This is something new. And like we want to repeat the same, so we can repeat the same uh, loop. So it will like insert the element of the first array twice. Like all the elements of first array will be inserted once. Then again from the beginning it will be inserted. So if we want to display this, it will like if we talk about the resultant array, now it will contain elements 1 to 5 and again from 1 to 5. Okay. So this is how we can approach the solutions to the problems. So like we are beginning with very simple problems to be solved. So as we'll move on, the like level of problems, complexity level of problems will increase a little. So I hope you all have understood this solution. So let us move on to the next problem statement. So I want all of you to go through the problem statement carefully. Here I will give you 2 minutes to think about the solution. Okay. And in fact, I want all of you to come up with solutions. Okay. So let me explain you the problem statement. The problem is like we want to find kids with the greatest number of candies. So there are n kids with candies and you are given an integer array candies where each candies I represents the number of candies the ith kid has, and an integer extra candies is also available with us, which denotes the number of extra candies that you have. Okay. So what actually we have uh, an array named candies. Okay. And it is an integer array, and like the kids are numbered from 0, 1, 2, 3, and so on, and like these values available here, okay, will represent that particular kid is having these many number of candies. Okay. And we also do have uh, another single integer variable which is representing that how many extra candies do we have with us, remaining with us. Okay. So now please pay attention what we are actually supposed to calculate and come up with the solution. We want to return a Boolean array. Okay. Boolean array will only have true or false as its element. So the size of Boolean array will be same with this. Like we want to Boolean array for all the kids, all the children. Definitely this Boolean array will store only true and false. So when this Boolean array will store true and when this Boolean array will store false, look at this given statement. Where result I is true if after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids. Okay, or false otherwise. So I hope now you all have understood the problem statement. So if we need to check for all the kids, all the children, and like whether by giving all these extra candies to that particular kid, that means by adding these extra candies to this value available in this array, candies array, whether it makes it the highest amongst all. If it does, then we will store true. If it doesn't do that, we will store false. Okay. So this is what the problem statement is. So what I want all of you to like plan for the solution, and I give you 5 minutes to plan the solution, and then I will discuss. Okay. Just think about it, quickly think about it. Like I had given you sufficient explanation. So you need to find the maximum, then iteratively You are supposed to add these extra candies to the candies available with each individual student, and then you are supposed to check whether the result becomes greater or equal to the maximum. And if it is so, you will store true in the corresponding cell in the result array. Otherwise, you will store false in the corresponding cell in the result array. Okay, so let us look at the solution. So, like, just pay attention to the logic here. So, there are two vectors, size, and like there is only one vector size, candies, and there is one integer variable that is extra candies. So we can use this size function to iterate through all the elements. Okay, and this section of code will give you the largest value among this candies vector. Okay, so again we can use max function, which is built-in function. So here we are using two built-in functions, size and max, to find the largest element. Okay, then now we will be creating a vector result whose elements are going to be Boolean values. And like I want all of you to go through this loop. Okay, so if the candy is available with the kid is added to the extra candies, that means if the extra candy is given to the kid, and if it becomes equal to or greater than maximum candies. Okay, and that is when we wanted to store true for the corresponding kid in the result factor. What we will do, we will push back true in the resultant array. Otherwise, like when this is not going to happen, we will be pushing back false into the result array. So this was very, I won't say very simple, but this was simple. Like what generally happens with us when we look at the problem statement, we do get overwhelmed by like, oh, this is going to be very difficult. So just like plan in the solution in steps and try to use as like library functions or templates as much as possible. So if you look at the problem statement, you will find, oh, this is a very big problem statement, how to solve this. But try to solve step by step, like try to understand what information is available, try to understand what is to be calculated, then plan how it is going to be calculated. If you go step by step, the problem doesn't seems to be very difficult. Okay. So I hope all of you have understood the solution to this particular problem with for kids with the greatest number of candies, and how this use of this library functions of size, max, push will help us in like in easy writing of the codes. Okay. Uh, Now I would like to discuss about a very simple problem of reversing a string. Okay, so this is a very simple solution of reversing a string. Here we can use a vector, we can use the size attribute, and reversing a string, what we can do, we can what we are doing here, we are swapping. How we are swapping? We are swapping the first element with the last element. Okay. In the first iteration of this loop, we are swapping the first element with the last element. Then in the second iteration, we will be swapping second element with the second last element, n minus first. And the same we will repeat till we reach the middle of the string. Okay. That's why we are going up to size by 2. So once we have swapped in this fashion, suppose your string is this. What we are doing? First we are swapping this. The string will become, then we are swapping this. Okay. And then C is the middle element. Since once we reach the middle element, we'll stop iterating. This is actually reverse of this string. This is very simple problem that we can solve reversing the string. Now I would like to have a break of 10 minutes. It's 10:50. We'll continue the discussion at 11. So like I'm keeping a problem statement open. So if you want to take a break, you can take a break, or if you want to work on this problem statement, you can work. And like after 10 minutes, I will start discussing about this problem statement.
Sure, sir. That would be
Okay,
great.
thank you.
Hello. So I guess we can start.
Sure, Aman. Give me a minute. So, I hope I'm audible and the screen is visible, Aman.
Yes, sir, it's visible, sir.
Okay, thank you. So, this is a problem statement for comparison of two strings, but this is a little bit trickier than direct comparison of two strings. So, what is the problem statement? Given two strings, return true if they are equal when both are typed into empty text editors, and here hash means a backspace character. Okay. So note that after backspacing an empty text, the text will continue empty. So like if there is nothing written and if we press backspace, it will remain the same. So like look at carefully to the examples, then you will get to understand what actually this problem statement asks for. So here, this is the first string, AB hash C. Okay. So this is the first string. This is the second string, AD hash C. And we want to compare these two strings. And if they are identical, we need to return true. Otherwise, it will return false. So in this case, if s equal to ab hash c and t equal to ad hash c, the output would be true. Why? Because this hash acts as a backspace. So if we talk about s, a, then b, then hash acts as a backspace, then b will be deleted, and the next character would be c. Similarly, in case of t, it will be a, d, again the hash behaves as a backspace, so d would be deleted and the next character is c. So s becomes sc and t also becomes ac. So they both are identical. So it will return true. Also pay attention to the second example, a b hash hash, a b hash will delete b and another hash will delete a. So s would become empty. T is equal to C hash, hash will delete C, then D hash, hash would delete D. So T would also become empty. So in this case as well, the output should be true. These two strings are identical. Okay. So how this can be implemented, just have a look at the solution. So I will give you a minute to go through the solution, like before trying to explain the solution. So here we are taking two stacks of characters A and B, and these two strings are supplied as arguments. So look at this first for loop, it will iterate through the characters of first string as, okay, and please pay attention. if the character is a hash, we need to do perform that backspace step. Okay. So we'll look at the else part first. If it is not a hash, we will push it onto the stack. Okay. And if it is a hash, what we will do? We will perform the backspace operation. That means we will be popping up an element from the stack. Okay, we will be deleting an element from the stack. And again, as we have discussed, if the editor is empty or string is empty, it will be represented by the stack being empty. If the stack is empty, we need not to do anything if there is a hash. So that's why this if condition. So if the stack is empty, this condition will become false and we need not to do anything. And if the stack is not empty, then hash will result in a backspace and it will delete an element. Okay. Same we will do with the second string. Okay. And now we will be comparing the elements of stack A and stack B one by one. Okay. And we will be comparing the elements until any one of them becomes empty. Like at least one of them becomes empty. So if any one of them becomes empty, this condition will become false and we will exit the loop. So we were comparing element by element and we can only peek through the top element. So we will be comparing elements from top to bottom. And like if the elements do not match, then definitely those two strings are not identical. We will return false. And then we will pop one element from A. Also, we will pop one element from B. Then we will compare the next characters and so on. So after few comparisons, one of the stack will empty if there is a what we can say if there is a different if there are different number of characters in these two stacks. So one stack becoming empty will exit the loop. So one stack would be empty and another stack will have few elements. But if all the characters are similar and if both the stacks become empty at the same time, in that case, we need to return true. Okay. So if both the stacks become empty at the same time, we need to return true. That it will represent that they are identical strings. So I hope you all have understood the solution explanation. So we will move on to another problem statement. So how can we can implement a stack using queues? Okay. So we want to implement a stack using two queues. So implementation of a stack using two queues means like we want to write this push and pop operations for a stack, but the elements will be stored in queue, and another queue like the elements of the stack will be stored in one queue and another queue will be used to like perform the operation. So how it will do, you can look at this code, how uh, like this is your supposed to be stack. This is the first queue where the elements of stakes are already stored. Q2 is an empty queue which will be used to perform the push operation. Okay. So to perform the push operation onto the stack, we are supposed to shift the elements from Q1 to Q2. Okay. So I would like you to like give some time and go through this code and try to understand, try to guess how this is working. So what we will be doing, like since the elements of the stack are stored in Q1, and if you want to push an element, okay. So what we will be doing, we will be emptying the Q1 queue and storing the elements into the Q2. Okay, so how it will be done? We will be taking front element from Q1 and we will be pushing or inserting it onto Q2. Okay, and like we need to also delete this element from Q1. Okay, so if the elements are like A, B, C, D, so after execution of this loop, this queue will become A, B, C, D, and this queue will become empty. Then we will push the element. Okay, we will push the element which we want to push onto the stack into Q1. Suppose if you want to push X, so now since this was empty, X would be stored here, and then again we will pick the elements from Q2 and then insert into Q1. Okay. So this is how we will be pushing, because we can only push at the top in case of a stack and at the front in case of queue. So like this original queue is a representation of the stack from uh, top to bottom. Okay. This was the original stack which was stored in this Q1. Then we wanted to push X. What we did, we shifted all the elements from Q1 to Q2. Then we inserted in Q1 the element to be pushed. Then again we have shifted all the elements from Q to Q1, Q2 to Q1. This is how we are performing a push operation for a stack, which is actually being stored as a queue. Okay, so all of you have understood this operation. And what about pop? Pop is simple because the top element is at the front position in the queue, and like in queue, the pop operation is also performed from the front position. So pop operation is simple. If the queue is empty, element cannot be deleted, otherwise front element is supposed to be popped. Okay. So this is how you can approach the solutions. What I would suggest, like, don't jump into writing the code straight. Plan the solution before, like build the logic first and then write the code and try to use the templates or library functions as much as possible to simplify. So we will end today's discussion by solving this particular problem. I will give you a minute to go through the problem statement. Like this is a little complex one. And I will again give you 5 minutes to try the solution at your own. Then we will be discussing about the solution. So the problem statement is number of students unable to eat lunch. To like carefully go through the problem statement. The school cafeteria offers circular and square sandwiches at lunch break. So the circular sandwich will be referred by number 0 and the square sandwich will be referred by number 1. All students stand in a queue. Each student either prefers a square or a circular sandwiches. Like the students will not accept any sandwich, they have specific choices. Okay. And the number of available sandwiches in the cafeteria is equal to the number of students. Okay. But it doesn't ensure that all of them will get the sandwiches that they want. Okay, like some of them, and we don't know the number of square and circular sandwiches, as well as we don't know the about the choice of the individual students. So the sandwiches are placed in a stack. Sandwiches are placed in a stack. Students are stand in a queue. And if the student at the front of the queue prefers the sandwich available at the top of the stack, it will take it. Like the student will get the sandwich of his choice and will leave the queue. Fine. Otherwise means if the sandwich available at the top of the stack is not the choice of the student standing in the front of the queue, then what it will do, this the student will not leave the queue, it will go back to the queue's end. It will leave the front position and will join the queue at the end. Okay. And this will continue until none of the queue students want to take the top sandwich and are thus unable to eat. Okay. This is supposed to be repeated until none of the students in the queue is going to take the is willing to take the top sandwich. Okay. So how you will encode it? If you are given two integer arrays, students and sandwiches, where sandwiches I is the type of the ith sandwich in the stack. Okay, so sandwiches is representing the stack. I equal to 0 is the top of stack initially. And student j is the preference of the jth student. And j equal to 0 is the front of the queue. Okay. The students is the queue, sandwiches is the stack, and like both of these will have values 0 and 1 based on the choice of circular and square sandwiches. So I will give you 5 minutes. Like this is a complex problem. Just go through the problem carefully and try to write the solution. Okay, so let's have a look at the solution. So again, I will give you a minute to go through the solution and like try to understand the logic implemented here. So we will be working with two vectors, students and sandwiches as stated in the problem statement. And we will be using a queue, like all the queue will also work here instead of DQ. So look at this. What we are doing, this sandwiches vector, it will contain the numbers representing the sandwiches available in form of the stack. Okay, so we will be pushing those into the queue. Okay, and here we are initializing two variables with 0, and look at the condition of this loop. Q size is not equal to 0 and k is not equal to q size. So please pay attention. If q dot front is not equal to sandwiches I, okay, so what we need to do, what the student will do, it will go back to the end. Okay, so the front student is standing at the front will be joined at the end. Okay, the student at the front will go back to the end in the same queue, and like we will increase this variable k here by 1. Okay, otherwise what does it mean? If this condition is false, that means q front is equal to sandwiches I. That means will have the student will have the sandwich of his choice. So we will again make k equal to 0 and we will increment I by 1. And in both the cases, like this q is not inside this else. Okay. In both the cases, like whether the student from the front joins back at the end or whether the student leaves the queue, we need to pop the element from the front. Okay. And this is what we need to do until q size becomes 0 or k becomes q size. Okay. So like if all the students are satisfied, the queue size will become 0 and we will return 0 as the number of students who will remain hungry. And if k becomes queue size, okay, k becomes queue size, then this loop will exit, and in that case it will be the number of students remained in the queue which are not having their choice satisfied. Then that will be the number of students who will remain hungry, okay, based on the problem statement. So that's all I wanted to discuss with all of you today. Like we cannot uh, have an exhaustive or very long list of problems to be solved. So we tried to discuss about a variety of problems which are related to variety of containers like vectors, stacks, and queues. So I hope this was helpful for you. And like sessions like these are only like to give you the initial spark. So you can continue working on uh, problem statements from the various platforms like lead codes, hacker ranks, and etc. And I hope like uh, these two sessions were of help. And you can also like put your queries to us. I hope Aman and team like is going to provide you some platform where you can share your queries
Yes,
with
sir.
us. Okay. So Aman,
Yes,
like
sir. They can
once,
always put it in the chat. Yes, sir.
okay. Yes, yes. And
So,
like you can like once you receive any query and like we can keep it open for few more days, like 1 or 2 days. So in even though if like they put their queries tomorrow or day after tomorrow, you can forward those queries to me, or like if it can be addressed at your end, we need to
yes, sir.
address their queries. Okay. So
Sure, sir.
thank you,
Sure.
Aman and team GDSC.
Yes, sir. So as our data structures and algorithm workshop day two comes to an end, I would firstly like to express our sincerest thanks to our distinguished speaker, Professor Piyush Kumar Soni. His extensive knowledge, expertise, and passion for data structure and algorithm have truly inspired us. We really appreciate your time and effort you put into preparing for this workshop and the invaluable insights and practical examples that you have shared with us. Your presentation has helped us better understand the core concepts of data structure and algorithm, and we are really grateful for your willingness to share your knowledge and expertise with us. We would also like to thank all of you for attending this workshop and making it a great success. We hope that you enjoyed the session and learned a lot from it. We look forward to seeing you again in our future event. So, thank you once again, and thank you, sir, for your time and your preparation. Thank you. So, I guess with this said, we can end this session.
Okay, thank you, Aman.
Thanks, sir.